So hello everybody, my name is Gustavo. I'm gonna talk about a project that I've been working for a few weeks now. It's I'm gonna show how I'm building a WebAssembly runtime for Neovim plugins. So essentially it's a mix of Neovim, Wasm, Rust, and Lua, and everything in between. So it should be fun. So currently I'm working at JetBridge. So if you have a cool startup idea, feel free to send us an email and we'll happily take a look and review. So a little bit of a backstory. This all started with me trying to build a Neovim plugin in Rust. And as soon as I started, I realized that I was going to face problems, especially around distribution. The thing about Rust is that it's a compiled language, and to build a Neovim plugin, you would need to build a dynamic library. This is the most common way to do it. And well, unfortunately, because of that, and also because Neovim runs in a lot of different places, this was going to be a problem, especially for the plugin that I was building on, because it was so simple, probably not worth it tackling this issue. So you will have to build, to compile your source code into multiple different combinations of operating systems and architecture. So this was probably not going to work for me. The other option would be to distribute the root source code and let users build themselves the dynamic library, which is not really ideal because maybe the user don't have the rules to chain, so not really what I want to do. Also, I want to maximize the number of users. So while I was looking for alternative, I realized that I could maybe use Wasm. I had a little bit of experience before using Wasm, so this seemed to be a great opportunity to explore that and learn more about it and learn more about Rust as well. So yeah, let's see about WebAssembly. So WebAssembly, as what the website's saying, webassembly.org. There's the description there. And the most important thing that I want to highlight here is that it's a portable compilation target, which it's very interesting, exactly what we want. We want to compile our source code just once and let the user run whatever they want without needing to change or anything like that. The other thing that it says, it's for the web. Well, I'm not really sure about the web part. Because yeah, you know, Neovim is not web, but well, it can be, but not for this project. But yeah, let's see if we can handle that later. So the way that WebAssembly works is that you write your source code. It usually Rust because it has very good support for WebAssembly, but it can be C, C++, or even Go. And what I mean by support is that you have a compiler that is able to create a .wasm file. And that WASM file is just a binary format. It's a bytecode that it's machine independent, which it sounds really good for us because, as I said at the beginning, we don't want anything dependent on the machine. When we have that WASM, we then feed into an engine. That engine is the one responsible for allocating memory and making the translation between the independent machine code of the WebAssembly to machine-dependent system calls, like Linux system calls or Windows system calls or whatever the user is running the engine. And this engine is usually inside browsers, Node.js, Dino, or in our case, Neovim. This is our end goal, right? So this is looking pretty good. We can build this .wasm file and share with the users, and they don't need to do anything else. They just want to, they just need to run that file in their engine. But the thing that is missing here is the engine. We don't have an engine already inside Neovim. So let's explore how we can put that inside Neovim. Wasm Time. So Wasm Time is a project by the Bytecode Alliance. And as you can see on their website, wasmtime.dev, there are a few things to highlight here in their description. It says that it runs outside of the web, which is pretty cool. I don't want dependency on the web. I just want to run Neovim without anything else. The other thing that it says, it's a library embedded into a larger application, which sounds pretty good. Neovim is our larger application in this case, and we want to embed that library so Neovim is able to run that code for us. So this is looking pretty good. Maybe we can use that. So after thinking a little bit and exploring the alternatives, I sketched what I want the project to do. So essentially what we have, it's a patched required function. This function is, as you may be aware, it's a Lua function that you can use to load external files. You probably saw from the previous talks. And right now you are able to use that function to load external Lua files, but with the patched version of it, you can also load .wasm files. And as soon as it identifies that it's a .wasm file, it will dispatch to our wasm time that would live inside the Neovim. And with that running inside Neovim, we will be able to run FFI code that it's exposed by the Neovim API. So essentially, as you can see, there's no RPC calls, there's no sockets being opened to run all those files and to run the plugins. And so I'm not expecting any bottlenecks in this besides the translation code and the glue code. And it runs the same process. It even shares memory besides sandboxing. I'm gonna show a little bit more later. So, but how does this actually work? Well, it starts with a api.wit file. In this file, as you can see on the screenshot, I specified all the API functions that I want to expose from Neovim. As you may be aware, this looks pretty common. This looks familiar to some of the API functions like the command, the create buff, and the buff set lines. The parameters are even very similar. Despite some of the changes, like some small changes. Yeah, and with that file and with all the functions defined, we feed into the WIT bindchain project, which is also from the Bytecode Alliance. That project has a couple of macros, which is the import macro and export macro. It generates Rust code for us to make this translation happen. This is pretty good, but it has some limitations, mostly around variadic function parameters. So it works pretty well if we know the function beforehand, we know the parameters that we want to expose and make the conversion. But for yeah, this works for the host and for the guest communication. But when we want to call guest functions, guest in this case means the WASM plugins. When we want to call guest functions, which we don't know nothing about it, we don't know the function name, we don't know the parameters, this doesn't work very well. So the way that I did to resolve that, I created a macro called Neovim wasm export, which you can put in your functions and in your Rust code, and it will automatically generate all the code necessary to make the translations between the types. One of the limitations of wasm is that it doesn't have high-level types like string. Everything comes down to pointers and numbers. So this was one of the main issues here that motivated me to create this macro. And also it exports the correct symbol so that the host, the wasm time, is able to load that from the module. And with all that, with both macros from the WIT bindchain and the Neovim wasm export that I created, we have full Lua and wasm interoperability. And well, as you can see here in the screenshot, there's a big unsafe at the beginning, which can be scary, especially in Rust, and also weird pointers being passed around. So I would advise to be careful with that. But what I want to highlight here is that this is one of the functions that make the translation work. And essentially, you can use whatever type that you want in your Rust code. And this, as long as it obeys to the traits that I created, you'll be fine. And the code will automatically translate these types for you. And with all that said, this is a small demo. On the top left corner, you see the Lua code that it's requiring the .wasm file, our real word .wasm. And you see that it's also calling two functions, my function and create custom buff, both functions passing parameters around. And on the bottom, you see the Rust code that I use to generate that .wasm file. You see that I'm also using the Neovim wasm export macro. And after running that, you see on the top right corner, on the number 3, you see the buffer that it created, that the Rust code created through wasm. And you can see that it created a buffer, injected some lines in it, and the last line is actually a parameter that was sent from Lua. So the next steps and limitations for this, as I said at the beginning, WASM and WASM time, they are evolving really fast. They lack some custom type. So everything comes down to pointers and numbers, as I said. But they're working really hard to make that easier for developers. There is a project coming up called WASM Component Model, which I'm really excited about it. So I'm paying attention to that. So as soon as it's ready to use, I'll definitely see what I can replace with that code to be safer for the users. The other thing that is missing is that I don't have all the Neovim API functions ready. I'm still working on it to write everything. I just created the bindings for the basic functions, mostly for testing, but I'm planning to add everything else later. There are a few rough edges, as you saw in the Rust code. The code is not very clean, so I'm planning to clean it up, make it very easier and clean for the users. The other thing is sandboxing and WASI. This is a big point for WASM. Sandboxing is essentially you let the users decide what they want the plugin to have access. So file system, sockets, and all the host resources, you will essentially limit what the plugin has access to. And WASI is basically a system interface, so std out, stdr error, and sockets and file system access. This is all done through WASI. Right now, there's a very rudimentary support for WASI. Only std out and std error are being piped to the Neovim log, but I'm planning to add proper support later on for more stuff. But those 2 points, they will probably need coordination with the core code of Neovim to not leak anything. So my next point would be to explore that, see what I can do without this, because right now it's essentially a plugin in Rust compiled so that Lua can load. So this runs inside Neovim, but what if we make that inside core? Would that be better, or would that be just like a gimmick? I don't know. There's a lot of room to experiment and try things out. And I would like to give special thanks to Ricardo. This is their GitHub profile. He's doing an amazing work on the NeovimNoxy crate. I'm learning a lot from it. This crate is actually, it exposes all the Neovim FFI code so that Rust can call it. So it's pretty amazing what they are doing. And I'm using this crate to complement my work. So it's, by the end of the day, we are using their crate. And yeah, special thanks to the Neovim core team and all the community around Neovim. It's pretty amazing what we are building together. It's also super fun. I'm really glad to be part of it. And yeah, that's it. If you have any questions, I'm glad to answer. And I'll probably open the source code in the coming weeks or coming months as soon as ready and not that messy with pointers and unsafe calls. But yeah. Yeah, I hope that the talk was not super low level.
I think it was pretty darn good. So let's jump over. We can actually field some questions. Do you want some questions?
Yeah, sure.
That'd be fantastic. Do you want to just come back, TJ?
Yeah, I'll come over here. I'm also trying to manage some other things, so I might look this way.
Yeah, right now we're trying to get the next speaker up in line, so if TJ's distracted, that's what's happening.
Yeah, that's fine.
This is pretty fantastic. We got a lot of claps going on, so if anyone has any questions, please do. No, just
yeah. Thank you for all the claps.
Someone's question was just like, can you talk about like a concrete use case of what would be the purpose of this project, right? So just like lay it out pretty simple, because I think a lot of people don't know very much about WASM or even necessarily writing plugins.
Yeah, sure. Well, the main thing is it's easier to compile. If you have a compiler that create the output.wasm file, we essentially just build in once, and you don't have, well, you don't have to share the Rust source code. It's great to share, but you don't have to let the users build by themselves. They don't have to have a huge tool chain to build that dynamic library. And the other important thing is the sandboxing. I really would like to see that happening, especially because you are now running binary code that you can't audit. So sandboxing would be a really cool feature to add to this, so that the scope of the plugin is limited to what you want them to have access to. So if you don't want the plugin to have access to a whole home directories, and then you could do that by sandboxing the whole plugin.
Sweet. Right.
Yeah, I mean, I think the sandboxing thing is really interesting. That's one of the really, really cool stuff for security for Neovim plugins, I think.
Yeah, for sure.
Some people were wondering about the performance aspects.
Yeah, right. So I want to do proper benchmarking. I haven't done it yet, but I'm planning to do later on. I'm mostly on the development phase. I want to see how it compares with running just straight out from Lua. Of course, it's not going to be the same as native code. It's going to be some overhead there because it's mostly around the type conversion, the translation, but I'm not expecting to be that slow. You see that the buffer, it created really fast, but it's a small thing. But yeah, we shall see the benchmarking coming up.
Nice. I think some people were wondering just about whether it's possible to write Neovim plugins in Rust, and the answer is already yes, right? I mean, that's part of the way that you're doing what you're doing today, right? And you said you were using NVim Oxy, is that correct?
Yeah, correct. So by the end, I end up with a Rust plugin that it runs inside Neovim, but it's a Rust plugin, but it has the capability to load the .wasm files and make the communication between Lua happen. So if you want to use just straight Rust, you can use the Neovim Oxy or just mlua directly. It will be fine as well, but you end up with the same problems that I mentioned at the beginning. Like you have to build dynamic libraries for the most common combination of architecture and platforms, and make sure that the users are able to compile themselves. These are things that I didn't want to deal with for the plugin that I started to build because it was too simple. It was probably not worth it, and I'll probably just be better writing it in Lua. But if we have this ability to load WASM plugins, then everybody will be able to easier build Rust plugins and not have to deal with those things.
Awesome. Very cool. I think this is pretty exciting. And with that, we're going to try and move on to our next speaker. So thanks a bunch, Gustavo. Gustavo, you have any socials or anything you want to plug before we say see you later?
Not really. I have my GitHub linked in the website. So if you want to follow, please feel free to do that and keep in touch. And I'm happy to answer more questions on this.
Very cool. Yeah. For those wondering, I think almost all of the speakers have their socials on neovimconf.live website directly. So you can go there and check and find them. So thanks a bunch, Gustavo. Appreciate
thank you.
Your time.